Welcome to Brain Vision.
Chapter 3, Problem 68 says arrange the atoms according to the decreasing effective nuclear charge experienced by their valence electrons. The atoms we have are sulfur, magnesium, aluminum, and silicon. The atomic numbers for these are 16, 12, 13, and 14, respectively. So to demonstrate this, let's use an atom. So we're going to do the smallest one, which would be magnesium. So we'll have 12 protons in the nucleus. The first energy level will have 2 electrons. The second energy level will have 8. The third energy level for magnesium and a neutral atom will have 2. And this will give us a total of 12. We have 2, 4, 6, 8, 10, and 12. So this is magnesium. The equation for effective nuclear charge is your Z effective is equal to the charge of the nucleus minus the charge of the shielding electrons. So the charge of our nucleus here for magnesium is 12, and we're going to subtract the number of shielding electrons, which would be 10. This is the outer electrons. On the outer energy level, the ones that are inside, or the core electrons, are shielding. So that minus 10 would give us 2. Let's make this same atom aluminum. In order to make it aluminum, we're going to erase this 2 and put a 3 here, which would give us 3 protons or 3 positive charges in the center. 3 in the center. We also need 13 protons in the center. We also need 13 electrons here. Putting an electron here did not change the number of core electrons, so we're still going to subtract it by 10. In this case, our shielding is now 3. Let's do the same with silicon. It doesn't have 13, but it has 14 protons in the center, which means it also has to have 14 electrons on the outside, so we will add 1 more. Again, the core number of electrons that are shielding these outer electrons does not change, so we're still going to subtract it by 10, giving us 4. And as you can imagine, similar with sulfur, we'll erase this 4 and put a 6 in its place, giving it a total of 16 protons in the nucleus. And the atom will have, therefore, 16 protons on the outside, has 14, 15, 16. This still did not change the number of core electrons, so we're still going to subtract this by 10 and end up with 6. So the effective nuclear charge of sulfur is greater than the effective nuclear charge of magnesium, aluminum, and silicon. Because we're adding electrons to the outside, the number of the same energy level, the number of core electrons inside does not change. Therefore, if we're arranging them in order of decreasing effective nuclear charge, we'll have sulfur, silicon, aluminum, and then magnesium.